suppose you have a basis, and suppose that I'm going to show that you can't throw out any of the elements. All elements are necessary if you want to span V. So I'm going to give names to the elements. B1 up to Bn, suppose there are n of them. And I'm going to define B prime to be B1 up to Bn minus 1. Right? Bn could be any vector, so I'm just going to throw out the one that I'm calling Bn. But if you want to throw out a different one, I'm going to call that one Bn and then throw it out. So that's B prime. So I'm going to show that B prime cannot span. Then there is no how about R, no scalars, A1 up to AN minus 1, such that A1, B1, AN minus 1, BN minus 1. So, right, this question is about proper subsets that span V. B prime is a proper subset. I threw out Bn. So I have a proper subset. If I don't have Bn, I'm going to show that you can't make Bn. It's impossible to make Bn. Assume toward a contradiction. So I'm going to assume that you do have that such A1, AN minus 1 exist. And what I'm going to get is I'm going to get something that's nonsense. When I get something that's nonsense, that means that I must have made a bad assumption. The only assumption I'm making here is this assumption. Then A1, B1, let's do that, plus AN minus 1, BN minus 1. These are the coefficients I'm assuming that I have, plus negative 1 times Bn. That's going to be equal to, well, if I group these two together, I'm assuming that these things equal Bn. Plus minus 1 times Bn equals 0. But not all of A1, AN minus 1, negative 1 are 0. In particular, the negative 1 isn't 0. So B1 up to Bn minus 1, Bn is not linearly independent. And by the way, this is equal to B. So B is not a basis. This is a contradiction. Why is it a contradiction? Because I can read. Because B is a basis. That's the first assumption. We're saying that B is a basis. So that it can't be that B is not a basis, so I must have screwed up someplace. Oh, I screwed up because I made an assumption. I assumed that I had such an A1 to A sub n minus 1. So no such A sub 1, A n minus 1 can exist. So no linear combination of the elements of B prime equal B sub n. Right? Because that's where the A sub n 1 up to A sub n minus 1 is. It's a linear combination of B prime that equals Bn. So B prime does not span V. And that's exactly what we're trying to show. We're trying to show that you have no proper subset that spans V. So if I throw out one element even, I can't make that element. I can't make it. Because if I could make it, then I'd do this, and I'd have that the original set was not linearly independent. It's not linearly independent, it's not a basis. But it is a basis, so that means I can't have these elements. And by the way, you can quickly amend this that if you want to throw out more than one element, then you could just do A1 up to AK maybe is not equals Bn, and you're going to get the same thing. So we've done it. If you throw out any of the elements, you're not going to be able to span V. So V is the smallest spanning set in that you can't throw away any elements. All the elements are essential. We're done.